Okay, so my project was an automated cat feeder. Um, so I was making this so I could just basically fill a hopper of food and set it and forget it, and hopefully it would work for a longer period of time so I didn't have to feed my cats 3 times a day. So somehow this project works. It feeds the cats in the home on a timer. It is pre-programmed to work on 12, 8, 6, 4, and 2 hours. That'll change to be more modular later down the line. And it also has a very powerful motor now, so it can handle any type of food. As I was having issues with larger particles of food getting stuck. So the hardware in this project, there's 2 Arduino relays, and the relays are used for the 24-volt DC motor. These get power from a desktop power supply currently. I don't have a 24-volt power supply for them right now. And it either spins the motor clockwise or counterclockwise to spin the paddle to dispense the food. The microcontroller in this that's programmed to run all this is a SparkFun Red board, which is basically an Uno clone. So it behaves exactly like an Uno would. Currently, the motor I have in there is a 24-volt globe motor, and it has a gearbox on the end of the mechanism to sort of gear it down so it has more torque, which was needed, once again, for larger food. So it would prevent binding in the project and the mechanism so it could dispense reliably. Yeah. Then I have a 16x2 LCD. It's an I2C, which uses a lot less pins, thankfully, as the Uno doesn't have a ton of I/O. On the first line of the I2C LCD, it shows the time, and I'll show you that on the next slide, and then it will show the feeding time, so when it's expected to feed again. The next piece of hardware in there is a RTC clock module. Oh, I guess that's a bit redundant. It's a real-time clock. So it's used to keep track of time for the microcontroller because Uno doesn't have a built-in real-time clock, and it's not very good at keeping time, unfortunately. I've had that issue in different projects as well. And then I have a mechanism that's inside the project. This was designed in AutoCAD Inventor, and it was 3D printed on my Ender 3. This is what spins to dispense the food in the feeder. So this would be my circuit that I have currently set up, and a mix of what I'm going to do in the future. So I have an Uno, the LCD, obviously what I mentioned in the past. The only difference is I'm going to change to the stepper motor that's here on the top instead of using the 2 relays. The current DC motor in there, I'd rather have a stepper motor in there, as a stepper motor is more precise, and I can move it as much as I needed or as little as I needed. This is currently the project. The enclosure is made out of pine. I made in my garage out of a 2x4 and some birch ply. Here on the top right, you can see the LCD. It's currently mounted on the back. That will change to the front. It shows the time and the feeding time. Obviously, that one's 12 hours apart. There's that DC motor with a gearbox on the front of it, and that's more temporary. The red button there is a manual feed button, so you can press that to feed on command. The bottom right, I have a battery pack in there for now to sort of power it remotely, not have to have it hooked up to my computer all the time. And so basically the flow of the software here on this project works by powering on, initializing the RTC, the LCD, and it'll save the starting time. So the way it currently works with dispensing is it saves the starting time, and then will feed from the interval you set prior. So if you set it for 12 hours, it's going to feed 12 hours from the time you started the machine. You set 8 hours from the time you start, and 8 hours after that, so on and so forth. Then it'll set up the pins for the relays in the manual button. It'll find the correct case statement for the inserted interval. So this had to be programmed into a switch. It'll idle, and either it'll wait for the time to match to feed, or wait for a manual feed button press, and then it'll go in and it'll run the shake routine. So the shake routine is to prevent binding and clogging in the unit. So it moves the motor back and forth as many times as you put it in. And yeah, so that prevents it from clogging up. And then it'll just spin for about 1 second afterwards to dispense the food. So the libraries I had to use in this project were the wire.h, which was obviously a dependency for the liquid crystal I2C library, and the liquid crystal I2C was for the LCD board to display the feed in time. Then the library after that is the RTC library. This was one I had found on GitHub that worked best for me, as the default one wasn't working for exactly what I needed it for. And this one's actually good at calculating future times for feeding and other things like that. The functions I use to program in this project was the shake function, which once again is the back and forth. It passes an integer, and that's how many times it'll move that motor back and forth. The dispense, which spins the motor clockwise for about 1.1 seconds. 1.1 seconds is about the time I figured with this DC motor to dispense about a bowl of food for one cat. Void and setup, every Arduino project will have these. And I went over the setup in the flowchart. And then the loop, which will constantly update the LCD. It'll check the time against the next feeding time to see if it's time to dispense food. And it's obviously waiting for if there's a button press for to dispense food. Troubleshooting. So the first issue with my project I was having was keeping time accurately, and that's why I had to go to an RTC, because it's not good at keeping track of time. But getting the RTC sort of fixed this issue. Those little cheap Amazon units are really good at keeping accurate time. But the biggest issue I kept running into, which took me days, and I hate it so much, was the mechanism that would actually dispense the food kept jamming. And first I had a stepper motor that I got on Amazon, and man, that thing would bind if there was any sort of resistance from anything. And so I obviously couldn't use that. And so I'd made the time smaller on the spinner that dispensed the food. And then I tried one of the 1 to 48 geared DC motors in the, I believe the current kit 129 classes having now. And well, it still worked with the 1 to 48. It still jammed often. And so I figured I needed a 17 stepper motor. And I figured that about 4 days ago. So I didn't have time to ship one and get it here and have it installed and work with my 3D printed parts. So I had borrowed that 24-volt motor from a friend. And that motor works great. And so that was most of the troubleshooting. This ended up being more mechanical time spent than software time spent for a software project, which was not ideal, but it worked out. So what I'm gonna do to improve this project in the future is have it feed more than one cat. So I have 3 cats, So I was either going to have either 3 spinning mechanisms and 3 chutes, or a triple chute that would hook up to the one single mechanism. Another thing considered is modularity, so making individual units that snap together with magnets I have a design for. And the voltage to power on the mechanism to spin would actually connect and go through the magnets on the side of the unit. Another thing I need to implement is a hopper level sensor to see when the food is actually low. Otherwise, it'll just spin and dispense nothing, which is not ideal. App integration to obviously tell you that level sensor, and if it successfully was able to spin, and a snapshot to make sure the cats were there. Another thing I had thought of last night was putting a speaker on it to play a tone, so the cats would know about a few seconds before it would dispense food, so that they all didn't just hear it dispense and then one cat would steal another cat's food. They'd all be there for the proper feeding time, which works out. Anyway, so after this, I'm obviously back off to OIT. Anyways, I like doing this project. It was fun. I like the freedom of having to make your own thing. I haven't had a technical class in a while that had let you build and do your own thing. It's usually pretty strict guidelines. And yeah, if there's anybody who has any questions, I can answer them.
Good job, man.
Thank you.
Great work, Zach. Nice way of making adaptions as issues started popping up on you.
I like everything about the resistance. That's neat, the way you accounted for it.
I had a completely different design when I started, 100% completely different. And then I had to just change it as it went along. Actually, I have it set up right here. I don't know if the lighting is going to be very good.
Yeah, we can see it.
But so it's powered by a desktop power supply behind it. And if it decides to work right now, I can press the manual feed button. And it dispenses a bowl.
That's awesome. Good job.
So it works pretty well.